Today it's about quadrilaterals. So if you talk about quadrilaterals, I keep them into three different categories. One type of quadrilateral which doesn't have a particular property. Okay, so what are the concepts that we need to know for a basic quadrilateral? Then second type of quadrilateral which is known as parallelogram. Now in parallelogram there are rectangles, then comes squares and rhombus. And then third type of quadrilateral which is very important, and it is known as trapezoid or trapezium. So we are going to learn these quadrilaterals in different part, and in this session we are going to learn about basic quadrilaterals. So let's say there is a quadrilateral ABCD and the side lengths, let's say A, B, C and D. Then what we can say about the relation between these side lengths? So as you must have known the properties regarding side lengths in triangle. So in triangle, what do we say? That any side is greater than the absolute difference between other two sides and less than the sum of other two sides. Similarly, in quadrilateral, we can say that any side length is greater than the minimum of the absolute difference between any two sides. Okay, so let's say that what we can say about any side length. So minimum of any difference of any two sides, so A minus B, then A minus C, then B minus C. These are three side lengths known to as. So the third side must be greater than this. Okay, minimum. And the largest side must be less than the third. So we can say sum of the rest of the three sides, means we can also say that D must be less than A plus B plus C. So these are the two properties that you should know about the side lengths in a quadrilateral. Now apart from this, what we can say about quadrilaterals, that let's say, how do we find the area? So let's say there is a diagonal AC and DE is perpendicular to AC, as well as BF is also perpendicular on AC. So how do we find the area? So area of this quadrilateral ABCD will be equal to half of AC into sum of the perpendicular lengths, which is DE plus BF. This will be the area of this quadrilateral. Okay, now apart from this, there is also another properties in a quadrilateral that we can talk about. Like if two of the diagonals of any quadrilateral are perpendicular to each other, like this one, AC and BD are perpendicular to each other, then what we can say, that the relation between the side lengths, we can say AB square plus CD square will be equal to BC square plus AD square. So remember this one. Apart from this, we can also say that area of quadrilateral ABCD will be half of product of the diagonals. Product of diagonals means AC into BD. So these are the basic concepts, basic formulae that you need to know regarding any quadrilaterals. Now let's check the questions and try to implement them. First question, it says the lengths of all four sides of a quadrilateral are integer valued if three of its side lengths are 2 centimeter, 3 centimeter and 6 centimeter, then the total number of possible values of the fourth side is, let's say fourth side is x. What we can say? X will be greater than minimum of the absolute difference between any two known sides. 2, 3, the difference is 1. 3, 6, the difference is 3. 6 and 2, the difference is 4. The minimum difference is 1. So x must be greater than 1, less than sum of the rest of the three sides. 6 plus 3, 9 plus 2, 11. So the fourth side must be greater than 1 and less than 11. So we can say this could be 2, 3 till 10. How many values are these? A total of 9 values. So our answer is option C. Now, next question, it says two sides of a plot measure 64 centimeter and 48 centimeter and the angle between them is 90 degree. The other two sides measure 50 centimeter each and the other three angles are not right angles. Find the area of this quadrilateral. So there is a plot where two sides are perpendicular to each other and other two sides are not perpendicular to each other, like this. So let's say this is A, B, C and D. Now it's given that AB is equal to 64 and BC is equal to 48. So can we say triangle ABC will be a right angle? And in that case, using the Pythagoras theorem, 48 is 12 into 4, 16 into 3, 48 is 16 into 3, 64 is 16 into 4. So AC will become 16 into 5, which is equal to 80. So AC will become 80 and it's given that the other two sides measure 50 centimeters. So this will be 50 and this will be 50. How do we find the area of this quadrilateral? So there is not any direct approach. We will have to find the area of this triangle ABC and then area of triangle ADC, and then we can find out the area of this whole quadrilateral. Okay. Now in this triangle, if I draw perpendicular to this, can I say this will be 40 and this will be 40? Now again, let's say this is F. AFD will become a right angle triangle. In this case, this will be 30. So we have two right angle triangle, or we can say what will be the area of quadrilateral ABC? Area of quadrilateral ABCD will be equal to, now in this case, it will be area of triangle ABC plus area of triangle ACD. So this gives us ABC half into 48 into 64 plus half into, what is base? Base is 80 AC into height is 30. So this into 30. Now this will be 24. 24 into 4 is 96, carry 9, then 144 plus 9, 153 plus this is 15 times. So this becomes 1200, which gives us 2736 centimeter square. And if you check the options, option D is our answer. Now next question, it says in a quadrilateral ABCD, diagonals AC and BC intersect each other at 90 degree. We have just learned this concept that in any quadrilateral, if diagonals are perpendicular to each other, just like this, so A, B, C and D. So diagonals AC and BC intersect each other at 90 degrees. So this angle is 90 degree. AB is given, which is 25. BC is given, which is 17. CD is given, which is 10. We need to find AD. So what do we know? In any quadrilateral, if diagonals are perpendicular to each other, we can say that AB square plus CD square will be equal to BC square plus AD square, or we can say that AD square will be equal to AB square, which is 25 square, plus CD square, which is 10 square, minus BC square, which is 17 square. So from there we can say AD square is equal to 625 plus 100 minus 289. So from there we get AD square is equal to 725 minus 300 is 425 plus 11, 436. So we can say AD is equal to square root of 436. Now in question it says find the length of AD to the nearest integer. Now think about this. 21 square is equal to 441 and 20 square is equal to 400. Can we say that square root of 436 will be closer to 21 rather than 20? Okay, so we can say this is closest to 21 and our answer is option B. All right, now next question. In a quadrilateral ABCD, diagonals AC and BC intersect each other at 90 degree. AC is equal to 28, BD is equal to 22. Find the area of the quadrilateral ABCD. So we already know that in any quadrilateral, if diagonals are perpendicular to each other, then what is the area? We can say area of quadrilateral ABCD is equal to 1 by 2 product of diagonals, which is AC into BD. So this will be half into AC, which is equal to 28, into BD, which is equal to 22. This is 11 times 28 into 11, we get 308 centimeter square, again, which is option C. Now next question, it's a really good question, so I would ask you guys, you can pause the video and try this question and then check the discussion. Okay. So this question, it says ABCD is a quadrilateral with right angles at A and C. Angle A is right angle, angle C is right angle. DE and BF are both perpendicular to AC. Find the length of BF. Length of BF if AE is equal to 4 centimeter, D is equal to 5 centimeter and C is equal to 8 centimeter. Okay, so you can ignore the options here. These options are basically not true, right? So we need to find the length of BF. All right, so how do we find the length of BF? Or if you want these answers to be true, you can find the area. This should have been find the area of quadrilateral ABCD. Find the area of the quadrilateral ABCD if A is equal to 4, D is equal to 5 and C is equal to 8. So how do we solve this one? Let's see. Can we say in this right angle triangle, if this angle is theta, this angle must be 90 degree minus theta. 90 degree minus theta. And so angle A is also 90 degree. If this angle is 90 degree minus theta, this angle will be theta. And in that case, this angle will be 90 degree minus theta, right? So 90 degree minus theta. Now can we say these two triangles are similar? Triangle AED will be similar to triangle ABF. Now in that case, what we can say that the length has been given. Length A is 4, means the side length opposite to theta is 4 and ED is equal to 5. So can we say in this case the side length opposite to theta, if I take this as 4x, then side length opposite to 90 minus theta, this will be 5x, like this, which is nothing but AF. Okay, now similarly in rest of the two triangles, if I take this angle as alpha, this angle will become 90 degree minus alpha, and so angle C is 90 degrees, so this will become alpha and this will become 90 degree minus alpha. Now check again, the side length opposite to alpha is 5 here. The side length opposite to alpha, this should be corresponding to 5. The side length opposite to 90 degree minus alpha, which is EC. EC has been given. What is EC? So EC is 8. So 5 is to 8. This is 5, this is 8. So against alpha, if this is 5y, this should be 8y, right? So can we say x is equal to 2y? If x is equal to 2y, let's remove x from everywhere. So this will be 10y and this will be 8y. So this is 10y. Now what will be the length of AC? Can we say length of AC will be equal to AE plus ED, or AC is equal to AF is 10y and ECF is 5y. We can say 15y is equal to A is given 4, EC is given 8, so this will be 12, or this is 3 into 5, this is 3 into 4. We can say y is equal to 4 upon 5. Now if y is equal to 4 upon 5, what we can say about 8y? 8y will be equal to 32 upon 5, and what will be the length of AC? AC is already given, which is 12. Can we say the area of quadrilateral ABCD will be equal to half of AC into perpendicular length from opposite vertices, which is, this will be, this is B, right? This is D. So DE plus BF. So this will be equal to half into AC is what? 12 into, what is D? D is given, which is 5. What is BF? BF we got this, which is 32 upon 5. So this will become 6 into 25 plus 32 is 57 divided by 5. So from there, this is equal to 1.2 times 57. So 12 into 7 is 84, carry 8. 12 into 5, 60, 68. So 68.4 centimeter square. And if you check the options, option A is our answer. So we had recently done similarities. So I thought a really good question based on similarities would really help you guys. I hope you enjoyed this question, right? So this is the end of first session on quadrilateral. We will be back with the next session on quadrilateral very soon. So keep watching.